we're going to look at something you have already had some experience with, and that's when we have the power of a product. So the power of a product says if you have A times B to the power of M, then you can simplify that by saying A to the power of M times B to the power of M. And we've already looked at an example of this. Last Thursday we looked at what if I had 3x squared to the third power. And we expanded it and we said, okay, 3x squared times 3x squared times 3x squared. So 3 times 3 times 3 is 27, and then x squared times x squared times x squared was x to the 6th. So we've seen this before. So why does it work? Well, 4 times 10 squared. If you were to follow your order of operations, you would do 4 times 10, which is, and 40 squared is 1600. So let's apply this law. What if it was 4 squared times 10 squared? Well, what's 4 squared? What's 10 squared? So what's 16 times 100? 1600. So it works. So if you know this law, then you can make your life easy, because you can't have powers to powers and it be simplified. So x to the third, y to the fifth, all to the fourth power. What would that simplify to? X to the 12th, y to the 20th. What if we had a coefficient? What if it was 4a to the 5th, b to the 7th, all to the third power? So 4 cubed is 64.
15.
Okay, we don't say A15. What do we say? A to the 15th, or A to the power of 15, or A to the 15th power. B to the power of 21. What if it was a little more complicated? So let's look here first. What is something I can simplify on the inside? Y to the 0 is just 1, so it cancels out, so I don't even have to think about it. Now 1/4 to the third power is 1/64. X squared to the third power, x to the 6th. Z to the third power, z to the 9th. Okay, so that's my first one. Okay, what can we simplify on the inside here? So no worries about that x, because x to the 0 is 1. Y squared to the 4th, so y to the 8th, and z to the 3rd to the 4th, z to the 12th. So that's a 3. Sorry, my little handwriting. It's a 3. Okay, so now let's simplify these with the product of powers. What's my coefficient? 1/64. I'm just going to write 64 on the bottom. X is the only one, x to the 6th. Y is the only one, so y to the 8th. And then z to the what?
21st.
Adding the exponents gives a z to the 21st. Power of a quotient says a over b to the power of m equals a to the m over b to the m. And you have already experienced this. You've seen it in action. 1/2 to the power of 4 is what?
1/16.
1/16. 2/3 squared equals what? 4. 3 squared is 9. So 2/3 times 2/3 is 4/9. So that's our numeric example. Let's take it up a notch. What if I had 5 squared over 7 to the third power? In exponent form, we know that 5 would have the exponent of what? 6. And 7 would have the exponent of what? 3. Now, because these are numbers, you would have to simplify. Let's expand this and try and make it easier. Okay, when you're looking at this, I know that it's tempting to say, okay, 5 times 5 is 25, 25 times 5 is 125, 125 times 5, oh, I need to write that down. And then I'm going to get that answer and I'm going to multiply it by 5. Then I'm going to get that answer and multiply it by 5. But because this is all multiplication, we can chunk it. What's 5 times 5?
25.
And what's 5 times 5? What's 25 times 25?
625.
So we know that these 4 multiply to be 625. And these 2 multiply to be 25. So then I only have to write down one multiplication, because am I giving you a calculator for this? No. Okay, so what is 625 times 25? So 15,625. And what is 7 times 7 times 7? This is where it helps to know your cubes 1 through 10. 343. Because I won't generally give you something much higher than that. Now, question, can I simplify this? What's nice about exponent form is it gives us a hint on whether or not we could simplify it before we even do any math. Okay, 5 is a prime number, right? 5 times 5 times 5 times 5 times 5 times 5. 7 is a prime number. 7 times 7 times 7. Is there any one thing that I can cancel out on the numerator or denominator in this expanded form? There's nothing that I can do when it's expanded. There's nothing I can do here. The only factor of this is 5s and things that are multiples of 5. The only factor of 343 is 7 and 49 and 343. And, yeah, so it'll make your life easier if you look at that way. There's nothing to simplify here. That's your answer. Okay, but what if I did have something to simplify? So a big thing is simplifying before you complicate. It could be tempting to be like, okay, 14 squared is 196. 7 squared is 49. But then you have giving yourself division. We don't want that. So look here. Can I simplify inside the parentheses first? What is 14 divided by 7? 2. Can I simplify the x's? No. Can I simplify the y's? Who has more y's? The denominator. How many more? Okay, so now I'm going to square this. Now I can say, hey, what's 2 squared? X squared squared. X to the fourth power. And y to the third to the second. All right, let's put everything that we've done together so far in an example. 2x to the negative 2, z to the third on the numerator. On the denominator, we have parentheses, negative z, x to the fourth, y to the fourth, times, open parentheses, y, z to the fourth, close parentheses, to the negative 2 power, close parentheses, to the negative 2 power. You cannot look at this and do it all at once. You have to take baby steps. The first thing you need to do is you look at the numerator and you say, hey, is there anything on the numerator that I can simplify? No, so I'm just going to rewrite the numerator. Now, there are 2 sets of parentheses on the denominator. Let's start on the inside set. Is there anything I can simplify here? No. So I'm going to apply this negative exponent as just a negative exponent. I'm not going to flip anything just yet. So y gets to the negative 2 power, and z to the fourth gets to the negative 2 power. Is there anything inside this set of parentheses that I can simplify? Yes. So this negative 1, can't see the 1, but it's there. It's still going to be negative 1. Let's look at our x next. Do I have any other x's? No, so it's just going to stay x to the fourth. Now let's look at our y's. Now, since these are on the same level, we're going to add the exponent, so it'll be y squared. And then we have z and z to the negative 8. So it makes what?
Z to the negative 7.
Z to the negative 7. And now all of this is to the negative 2 power. So now let's take this and apply the negative exponent. We're not going to flip anything yet. Not into flipping anything just yet. Negative 1 gets a negative 2 exponent. X to the 4th to the negative 2 becomes what? X to the negative 8. Y becomes Z becomes, so if I have negative 1, or I'm sorry, 1 over negative 1 because it's on the denominator, and I move it to the top because it's got a negative exponent, the exponent becomes positive. And what is negative 1? I'm sorry, what is negative 1 squared? 1. So that doesn't matter because it's just a 1. Now if that was an odd exponent, we'd have a little more to think about. But because it's even, easy peasy. So this 2 is still a 2. Who has more x's, the numerator or denominator?
Numerator.
The numerator. How many more?
6.
Who has more y's, the numerator or denominator?
Numerator.
0 is more than negative 4. Or you could just say, hey, this is a negative 4, so we're going to move it to the top and give it a positive exponent. And who has more z's?
Denominator.
Denominator. How many more?
11.
Yes, excellent. Whew. Always get worried. All right. But did you see, I did not just immediately go from the problem to the answer. 2x y to the negative 1 times 2x for our numerator. And on our denominator, 2x to the 3rd, y to the negative 2, x to the 0, y to the negative 1 squared. All right. Numerator first, then the denominator, and then we can compare the two, and then we deal with any negatives that we have left. So this is it. This doesn't have any exponents, so that's nice. I mean, it does. It's a 1, but there's nothing changing anything. So I have a 2 times 2. So what do I have? 4. X times x, x squared. No other y, so it's y to the negative 1. Okay. All right, so with this denominator, I have an exponent out here, so I'm going to just rewrite 2x to the 3rd, y to the negative 2. Oh, look. What happens to x to the 0? Cancels out. We don't need it. Y to the negative 1 squared is y to the negative 2. Okay, so this 2 right here is still right there because there's nothing to multiply it with. X to the 3rd, x to the 3rd. What happens to the y's? Y to the what? Negative 4. What's 4 over 2? 2. Who has more x's? The denominator. How many more?
1.
Okay. And who has more y's? How many more?
3.